Okay, so test 8.2A, this is covering the exercise 8.2, okay, class 10 maths. So introduction, we'll start with the first one. That is, the question is find the values, okay, values with proofs. So we have to provide proofs of the trigonometric ratios of the trigonometric ratios of 45 degree. Okay, so these questions can come in exam to prove and find the value of 45 degree. So here, for that, let us take a triangle here. Let's say we have a triangle here, a right triangle. So this is the right triangle provided A, B, C with 90 degree at the point B. Okay, let us introduce this triangle. Let triangle ABC be such that, okay, with such that angle B is obviously the 90 degree point. Then let us say this angle here is 45 degree. Yes, we have to find for 45 degrees. So let us say here angle C equal to 45 degree. Now, having done that, now let us take this one. Angle C plus angle A will be equal to, or we can just do here angle C plus A plus angle B equal to 180 degree. Because we know this simple theorem that since sum of angles of a triangle is always equal to 180 degrees. Sum of the three angles is any triangle, the sum of the three angles comes out always 180 degree. So right here C is, we can see 45 degree, plus A is yet unknown, so B is here 90 degree is equal to 180 degree. So plus 45 and plus 90 is, I think, 135 degree. Okay, 135 degree plus angle A here equal to 180 degree. So we have here angle A, just keep it on the left side, and here 180 degree on the right side. And if we were to move this plus 135 to the right side from left side, then it will become minus 135 degree. So when we subtract this 135 subtracted from 180, as we can see here, no sign, so plus 180, and in front here minus 135. So plus and minus means subtraction. 10 minus 5, 5. 1 borrowed to make it 10 here, so 7 minus 3 is 4. So we found that angle A is also 45 degree, just as C is 45. Therefore, we see that both this angle C and angle A are equal to 45 degrees. Here C 45 and A 45. So these two angles are equal, C and A. Therefore, the sides opposite to them will also be equal, because there's a theorem which says that if two angles are equal, then the sides opposite to them. So angle C means the two arms that make this angle C are CB and CA. So the opposite side is AB, opposite side to angle C. Then angle A, the two arms of angle A are AB and AC. So the side opposite to this angle is the one which is not the arm of the angle A, which is BC. So BC is the opposite side to angle A. So these two sides are opposite to these two angles, and they will also be equal, because we know the theorem that sides opposite two equal angles in a triangle are always equal in length. The two angles are equal, so the sides opposite to them will be equal in length measurement. So something like AB is 5 centimeter, then BC also will be 5, right? So the two sides are equal. So let us assume here, as we have proved they are equal, let AB equal to BC equal to A units. So AB A unit, BC A units. So the hypotenuse remain unknown now. So SC is the hypotenuse because the two arms of 90 degree in this triangle are BA and BC. So the one which is not the arm here, SC, is the hypotenuse. So we can find it out as we have learned earlier also by using Pythagoras Theorem. The third unknown side in a right triangle can be easily found out by using Pythagoras Theorem. So here the unknown side hypotenuse SC square will be equal to the sum of the squares on the other two sides, AB square plus BC square. Pythagoras Theorem, AB square plus BC square. So that will imply SC, if you were to remove the square on it, then root will come on the right side, and AB is A value, see here, as you can see, ABA plus BC also here, A. So square and square. So S square plus A square is nothing but A square plus A square is 2A square, just as x plus x is 2x. So 1A square plus 1A square, because no number in front means 1, right? 1A square plus 1A square is 2A square. So root 2 can't be removed, so we just write root 2. A square means the root 2 into A. So these two couple can come out of the root as a single. So A is now out of the root. So having found that, we have the question mark value as root 2A, which we need not write also actually, but to help us solve, we're writing it. Now we're ready to determine the t ratios of 45 now, because all the three sides are known, A, and root 2A. These three sides we can determine the value of sine 45, or the trigonometric ratio values of 45 degree. So for that, let us write here in right triangle ABC, the one we have taken in the beginning, we have here, we'll take angle C, okay, as the reference angle, 45 degree. And then A also 45, but we'll just take C equal to 45 degree. Then AB equal to BC. Okay, I can just write here AB equal to A, we found out. We have assumed BC equal to A. And hypotenuse value we got it as root 2A. So in this right triangle, all the three sides are known to us. We have taken one of the angle as 45 because we have to determine for 45 degree. We can even take A also actually, up to us whether we choose to take the reference angle as C or A, because both are 45. So I will write here sine angle C in this right triangle, means C here. So if you take C, the two arms are BA, CB and CA, so the opposite comes here. Now the two arms of 90 degree are BA and BC, so the hypotenuse comes here. And the one unmarked here is the adjacent, BC. So we know sine of any angle is opposite by hypotenuse. So opposite here, as you can see, is AB, the length AB, by hypotenuse is here, capital H, AC. So that is AB is value A, as you can see here, SC value here, root 2 into A. So this A and A cancel, means sine 45 degrees 1 by root 2. So like that we have to find the trigonometric ratios for the remaining 5 for 45 degree. So we can write here, that implies that is sine of C, as you can see, is 45 degrees 1 by root 2. First answer. Let's go and find the rest here. Second one is cos. Therefore, directly I'm putting 45 degree, meaning the 45 here is C. So adjacent by hypotenuse. We can do directly now. Adjacent here is BC. Or if you want to write adjacent by hypotenuse, BC by AC. BC by hypotenuse AC. A by root 2A again. So these two cancel. So cos 45 is also 1 by root 2. We notice the sin 45 and cos 45 degree has the same value. The next trigonometric ratio is 10 45 degrees opposite by adjacent. So here opposite is O here, as you can see, which is AB. By adjacent here, as you can see, capital A here, we have marked BC. So AB is A and BC also A. So A divided by A means 1. A number divided by itself is 1, right? The rest are the reciprocal. So reciprocal of 10 is cot. So cot 45 is adjacent by opposite. So you can, once you get comfortable, you can skip this step, okay, if you want. So reciprocal means denominator of 10 will go up. Numerator of 10 AB will come down. It's called reciprocal. So reciprocal ratio of 10 45 is cot 45. So that is simply A by A. Same thing again. So this is equal to 1. Reciprocal of cos is sec. We know that sec 45 degree. Reciprocal of sec means this AC will go up, BC will come down. So this here root 2A will go up and A will come down. So cancel means root 2 is the value. Finally, the reciprocal of sine is, we know, cosec 45 degree. So reciprocal means this one here. AC will go up and then AB will come down. So this root 2A will go up and A will come down. So these two cancelled means root over 2. So the T ratios for 45 degree for all the 6 trigonometric ratios, sine, cos, tan, cot, sec and cosec are found. This is how we can prove it. So we have provided a proof with geometric figure. That's the proof to show that this is provable. Next question, we have to T ratio for 45 is done. Now 30 and 60 we have to do. So let's go and do that. Okay, so let's next question. You can go, the first one is question 1 and the next one is question 2. Okay. So trigonometric ratios. Okay, so here 45 is done. Question number 2. So trigonometric ratios, find the values. Find the values. Okay, values with proofs, just like the first one with. So we have to provide proof with right triangle, geometric figure of the trigonometric ratios of the trigonometric ratios of 30 degree and 60 degrees. So we have to find the 30 and the 60 we have done for 45. So for that, let us take an equilateral triangle. Now, equilateral triangle means a triangle in which all the 3 sides are equal. The primary definition of equilateral triangle is a triangle whose 3 sides are equal. That means AB 7 centimeter and BC also 7 and AC also likewise 7. So let us introduce the triangle. Let equilateral. So to prove for 30 and 60 degree, take equilateral triangle. Equilateral triangle ABC be such that, okay, the 3 sides AB equal to BC equal to AC. Let us say 2A units. So this is 2A unit. AC also 2A unit. Just come down a little bit, and this BC is also 2A units because the 3 sides are assumed to be are equal. So we just assume it to be 2. We're putting 2, we can use A also, but we're putting 2 in front because it's easier to cancel and get the values more easily that way. And then another condition of right triangle is that the 3 angles are 60 degrees. So angle B and angle C here, 60, and the third angle there is to write BAC. Okay, angle B equal to angle C equal to angle BAC, all of them 60 degree, because this is equation number 1, let us say, and this is equation number 2. So now let us do a construction. Draw a line from the vertex A, AD, perpendicular to BC. So from here we draw a straight line making 90 degree to AD, 90 degree to BC. So that is our construction. Now once we do that, let's take these 2 triangles here. We're going to prove they are congruent. So when we're trying to prove 2 triangles are congruent, we must be mindful of the position of the 3 vertices. The 3 vertices mean the 3 sharp points in the triangle. I'm going to take this triangle on the left and on the right of AD. So if we were to go here, A, D, B, if I chose like that, A, D, B, then I should go in the same style for the other one. I went from AD to B, so AD to C. So if we go ADB and we go SCB without minding the position of the vertices, the 3 letters, position is important to be in the right position. D is in the second place, C, like that. So the second triangle must follow the pattern of the position of the 3 letters of the first triangle, otherwise we'll get it wrong down there. So here, let us do this. Let us put this one as angle 1 and this one as angle 2. Okay, so you can just put your angle 1. Maybe you can put your angle 1, this one, from here to here. ADB is angle 1. So angle 1 inside ADB, triangle ADB, equal to angle 2 inside. Okay, let's just write here more. Okay, so here you can do like this. Maybe you can make it a little bit bigger. So here, this is 90, this is also 90. So this is 1 and this is 2, let us say. So angle 1 equal to angle 2, because each being (90 degrees). Okay, so here, now that means the 2 triangles are right triangles, because in a triangle, if one angle is 90 degree, that is a right triangle. So let's take the first one here. 1 is 90 degree, means the 2 arms of angle 1 are DA and DB. So the one which is not is the hypotenuse. Don't mark this, okay? I'm just marking for our sake. H1, AB. So spot out the hypotenuse for ADB. Likewise, do for ADC. So here angle 2 in ADC, triangle ADC, is the 2 arms of 90 degree. Angle 2 are DA and DC. So the hypotenuse is the one which is not the arm here, SC, H2, let us say. Let us not mark. So that is SC is the hypotenuse of angle triangle ADC. Are they equal? And if you look up here, AB here, they are equal to 2 units. Both of them equal to 2 units. Since using equation number 1, we know that AB already established to be equal to SC. In equation 1, AB equal to SC equal to 2A. So let us take these first 2 letters here. AD is the side, one side of triangle ADB. See, AD is the side of triangle ADB. AD is also the side of triangle ADC. First 2 letters and C, first 2 letters. That is called corresponding sides. They are equal because this is a common side to both the triangle. AD, meaning AD belongs to both the triangle. AD is the side of triangle ADB as much as it is the side of triangle ADC, right? So there is one theorem which says that if in 2 right triangles, like one angle is 90 degrees, so these 2 triangles are right triangles, their hypotenuse AB, that of triangle ADB, and the hypotenuse AC, that of triangle ADC, are equal, and any one of the remaining two sides here, AD equal to AD, then the two triangles are congruent. I repeat, if in two right triangles their hypotenuse are equal, and any one of the other two remaining sides, not necessarily both, but any of the other two remaining sides are equal, then the triangles are congruent. So we write your triangle ADC congruent to triangle ADB by the congruency condition called using RHS congruency condition for triangle. RHS tells us that in such a case the two triangles are congruent. Now congruent triangles simply means the two triangles are same in shape and size. Okay, that's the basic meaning. And when the two triangles are congruent, corresponding sides are always equal. Corresponding sides means, here, let us take this. Don't write this, okay? I'll just mention here. Or you can also write on your rough corner. Here, corresponding side would mean first two letters AD and the first two letters, that is called corresponding. They will be equal when the two triangles are congruent. For example, first two letters AD equal to first and third AB, that is not corresponding. So they have three sides, so there should be three sides equal. So DC, next is second and third, let us take. So second and third is DC, second, third is DB. That's correct. Or you can also write BD also, that's up to us. Once second and third, that's second and third, third and second, same thing, okay? So just second side, second corresponding side. Three are possible because every triangle has three sides. So first and the third letter is C, first and the third letter. That's true. When two triangles are congruent, the corresponding sides are equal. Okay, so which one do we need? We know already the value of AB and AC, 2A, as you can see. So we want to find BD and DC. So BD and DC. So let us take this one, DC and DB or BD. And reason is corresponding parts of congruent triangle, CPCT. Okay, CPCT. CPCT means corresponding parts here mean the sides of the triangle corresponding sides will be equal, and corresponding angles also. You need not write that, okay? So here, that is, we can write now DC equal to DB. Now you will notice that DC and DB together make BC. So since they are equal, each of these two parts are exactly equal to each other. So they will be equal to half of the full line BC, by common sense also, BC, right? So we write here, that is DC, okay, so we can write here equal to half into BC here, if you see in equation 1, 2A, so we can replace it by 2A and write here, since using equation number 1. So 2 and 2 cancel, so we get here A, equation number 3, let us say. So DC and DB both are A units now. So this is A unit and this is A unit. Okay, so this is equation 3. Now let us take the angle. This angle here in ADB, let's say BAD. So I will, okay, we can just write angle 3, and this one is angle 4. Okay, then we don't need this H2 and H1, so let's just remove it. So 3 and 4. Angle 3 is inside this triangle ADC, ADB. Okay, ADC. Okay, so DC equal to DB. So ADB and ADC are congruent, we have written. So angle 3 inside ADB, this one is equal to, then this triangle ADC, angle 3 inside ADB is at which vertex? ADB here, at the vertex A, means first position. So what is the angle at the vertex first position? That is called corresponding. Corresponding angle means angle A. So angle 3 is at vertex A of first position of triangle ADB. So the first letter here is also A. So what is the angle at the point A in ADC? ADC, that is the corresponding 4. So they are equal. Okay, they are equal because we know again CPCT, corresponding parts of congruent triangle, are equal. So just as corresponding sides are equal, the corresponding angles will also be equal. So therefore we can write here angle 3 equal to angle 4. Okay, angle 3 equal to angle 4 equal to, now 3 plus 4 is BAC, the full angle. So we write here angle BA, half of angle BAC equal to half of angle BAC, half of angle BAC. So if we were to go, that will be equal to, okay, you can just do it here, I think. Yeah, see, that is equal to half of angle BAC here. And equation number 2 is 60 degrees, so we can write here 60 degree, and you can write here, since using equation number 2. Equation number 2 says BAC is 60 degree. So if we cancel here 2 by 60, then 2 into 30 is 60. So finally we can write here, that is, we can write angle 3 equal to angle 4 equal to 30 degree. You can put this one as equation number 4. So now we are ready. One more thing before we go. So just will be, okay, so here AB equal to BC equal to AC equal to twice A. Then angle B equal to angle C equal to angle BAC equal to 60. That one, just skip it. Now let us do here. Slowly. From there, let us come from here. Now let us take this triangle here. And write triangle ABD. You can take any one you like. ABD on the left side or ADC on the right side. ABD or ADB, whatever you like. ABD, ADB, it's up to you now. We're going to take one of this right triangle on the left or on the right. Don't take both, okay? So we have here, here see, this side is known. AB is 2A, BD is A. BD is A from equation 3C. But we don't know this AD yet, so let us find out by Pythagoras Theorem. Using Pythagoras Theorem, by using Pythagoras Theorem, this one here, unknown one, AD square, is not a hypotenuse, so we know the Pythagoras Theorem. So it will be a hypotenuse square here. Hypotenuse is AB, that of right triangle ABD. So AB square minus BD square or DB square. So that will give you equal to here. That implies AD will be equal to root over square removed, then root AB. As you can see here is 2A. So 2 factor 2 and A. So we must put a bracket. Otherwise it's wrong, minus BD. BD, DB is same, so BD is A. So A square, no need to put bracket because A on the alone is the factor. So they will give you equal to root over, here root over, 2 2s are 4, A square minus here A square. So if you continue, that will be equal to 4A square minus 1A square is root over 3A square. 4 minus 1. So root 3 can't be removed, so we just keep it there. And A square will come out as single A out of the root. Equation number 5. Keeping equation 1, 2, 3, 4, and 5 in our mind. Let us now to this one. Now you have already written, so I'm going to wrap out. Here I'm going to put a 3, okay? So just to remember easily, just to save some space here, DC equal to DB equal to A. Here, this one, equation number 3. So here 3, and I'm going to just wrap out. You have already written, so this portion I'm going to wrap out. So here, now let us find the trigonometric ratios for 30 and 60. They say we can start with 30 if you want. So let us go to in right triangle ADB. You can take ADB or ADC, up to you, okay? This triangle, which is the 30 degree here, see. Angle 3 is the 30 degree inside that one, this one. So let us write here. Angle 3 is the 30 degree because we want to find out for 30 degrees. So you can just write a heading here for 30 degree now. We're using ADB, so 30 degree. Then there's 3 sides, let us 90 degree point, let us. Okay, that's enough. The 3 sides we'll let us write out to make it easy for us. AB is 2A. Then BD is A. And AD is, just now we found out AD is root 3A. Right, so let us write here root 3A. And all these things we are coming from using equations. 30 degrees coming from equation 4, comma, AB2A coming from equation 1. Then BD equal to A. BD equal to A coming from equation 3 here, as you can see. Equation number 3. So we are 3. And finally, AD equal to root 3A here is coming from equation 5. So the reason for writing these values here are equation 4, 1, 3, and 5. So now we are ready to find the T ratio for 30 degree. So I'll just write once here, sine angle 3, because angle 3 is in 30 degree. Inside this angle 3, the ADB, the two arms are AB and AD. So BD is the opposite side, right? And then AD is the adjacent and AB is hypotenuse. So we know the sine of angle 3 equal to opposite by hypotenuse. So opposite side, that of angle 3 is BD, by hypotenuse is here AB. So we can write the next step, that is sine angle 3 is here, we can replace by 30 degree, is equal to BD. Here you can see BD value is A divided by AB 2A. So this A and A cancel, means 1 here. So value of sine 30 degrees is half, the first one. Right, so angle 3 equal to 4 equal to this part. We can just wrap it up because already here given. So let us write it like this so we have space. So let us write here DC equal to DB equal to A. Let this be equation 3. You've already written, you don't have to write, okay, this one. And for space I'm writing it in. Then here angle 3 equal to angle 4 equal to 30 degree, equation number 4. And 5 here. So here 3, 4, 5, 1, 2, 3, 4, 5. We need those. So fair value of sine 30 degree we have proved is equal to 1 divided by 2. Likewise, similarly, you can just write like this if you want. Cos 30 degree, now we'll do directly. 30 degree mean the angle 3 here is adjacent by hypotenuse. So adjacent by hypotenuse means for 30 degrees here, adjacent side is AD by hypotenuse is AB. We're using triangle ADB, that's why. So AD here, as you can see here, is root 3a divided by hypotenuse AB here, value is 2a. So cancelling these two values, we are going to get here root 3 by 2 as the value for cos 30 degree. So we can continue. Okay, so here I think I'll just write these things here so we have space here. So here we don't need these things now. Just here AD equal to root 3a. So I'll just write directly here. AD equal to root over 3a is equation number 5. Let's write this one down. AB equal to BC equal to AC equal to 2a, equation number 1. And here angle B equal to angle C equal to angle BAC equal to 60 degree, equation number 2. So 1, 2. Okay, 1, 2. Equation number 3, 4, and 5. So we can wrap. The point is no need to write that, you have already written. We can have space here now to do the rest. So sine 30 degree, half cos 30 degree, root 3 by 2. Next is tan. So tan 30 degree in that triangle ADB is opposite by adjacent. So opposite to that of angle 330 degree is BD. By adjacent is AD. So that will be equal to, okay, we can write it here, equal to DB here A by AD here root 3